Hi, my name is Masood and we are in UIT Power Systems Lab. This video is for training of the power system. We're going to show you how to work with the lab volt units. This is the station that you're going to work with. Basically the station has the main power supply unit that gives you a couple of fixed and variable three-phase or single-phase AC or DC power sources. Then you have the data acquisition module here that gives you the ability to measure either the voltage or current. For current you can measure up to 4 amp or 40 amp. They have different inputs and terminals. Then we have the resistive loads here. You have a couple of options for the resistive load. You can combine the different resistors together to make different values, but each terminal can give you the 1200, 600 or 300 ohm resistive load. We have also the inductive load. Similarly, there are different terminals that can give you 3 options for each terminal, and you can put them in series or in parallel to make different inductive loads. And then at the end we have capacitive loads. So similarly we have each terminal having 3 values for capacitors, and you can put them in parallel or in series to come up with different values of capacitance. So now we're going to start implementing a circuit. This would be one of the simple circuit, including a resistive load 1800, an inductive load 2.4 Henry, and a capacitive load 2.2 microfarad. And it's connected to a 60 volt AC power source. The goal would be to see the voltage across the resistor and to measure the current of the circuit. So what I do, I start from the power supply. So the power supply that we have here, I need 60 volt. You can see here that I have to use this AC variable one, which is from 0 to 120. The voltage is going to be selected by this knob. So I start with the cables here. So the cables are in different colors, so it's better for the sake of troubleshooting to use the specific colors of cables for specific purposes. I suggest to use the blue for connecting the power supply. So what I do, I connect one to number 4 and one to neutral here, and I have to make sure that I choose the selector so that it addresses 4 to neutral, and 1, 2, 3, 4. This one, you see it's choosing the 4 to N to neutral. So this means that when I turn this knob, the voltage between these two is going to change. So I am going to connect this to start, let's say, with the resistive load. So I start from here. My resistor value was 1800. For 1800, I need a 1200 and a 1600 in series. So these keys here, these switches here, are to activate or deactivate the resistor. So I need a 1200, so I put the key, the switch up, and then I need a 1600, so I put this switch on, and I make these two in series. So I'm going to use the, let's say, a small cable here to connect these two together to make them in series. So that would be my resistor now. Now I have to go from this resistor to the inductor. For the inductor, so end of this resistor now goes to beginning of this inductor. My inductor was 2.4 Henry, so I have to put 2 inductor in series. I'm gonna put the 1.6 Henry, which is this one, on, and then the 0.8 Henry, which is this one, on, and then I make these two in series again. So these two in series. Don't forget for inductors to add them, you have to put them in series. And now this end has to go to the capacitor. So I need a longer cable. I'm going to use this one. That goes to, I need a bigger one. So I always can extend them. Try to use the same color to extend them. So this goes to capacitor. My capacitor is 2.2 microfarad, so all I need to do is just to turn the first switch on. That's the switch for 2.2 microfarad, and that would be the end which goes to the neutral. So my circuit, I quickly repeated. I started from this one. I made sure the selector was on. I went to resistors, 2 resistors in series, going to inductor, 2 inductance in series, going to capacitor. I only needed 1 capacitor. This is going here. So this way the circuit is finished. Now I have to measure the voltage and current. I suggest that you start doing one by one, because based on the experience, if you put all the meters, then if you cannot get any value from 1 meter, you have to just follow the whole circuit and whole meters, which would be a little bit difficult. So go step by step. What I'm going to do, just to measure the voltage. So to measure the voltage across the resistors, I need to connect to both sides of the resistor. So this is one side of resistor, and this is another side of resistor. So these 2 sides need to be measured. So for here, I connected to E1 on the data acquisition module. So what I do now, I go and turn on the panel at the end, and then there is a switch here that gives you 24 volt. Make sure that the light is on the DAC module. And then you have to connect the USB. So this is my USB cable. So USB is connected to DAC module, and the other side goes to the computer. Try to put the USB run from the back of the table's leg for safety, so it's not going to be a trip hazard for you. And then we have to run the software. The software is called LVDAC. LVDAC EMS. Okay, when you run the LVDAC EMS, you gotta make sure that here, this unit, the most important one, the computer-based instrumentation, or which is our DAC module, is recognized and is detected. We have other modules which is not related to this experiment, but the most important one, the computer-based instrumentation, make sure it's on. Make sure that this is 120 volts, 60 hertz. Here it's supposed to be none. And then you say OK. Make sure when you click on OK, you hear a clicking sound after a few seconds. So I hope I was able to capture that click sound. But even without that, make sure at the top, bottom right, it says hardware connected mode, meaning that it's connected, is not running in the simulation mode. So now I have 2 options. The first option is that go through the meters, or the second option is just to monitor it by oscilloscope. So let's monitor it, use the oscilloscope first. So the oscilloscope is here. You click on the oscilloscope, and the oscilloscope window opens up. Then I have to set up the channels. So if I click on this arrow, it says input off. So I have to click on it and change it to E1. Why? Because E1 was connected to the sides of the resistor, across the resistor. So when this is on, the next step is just to turn the power on. The voltage was supposed to be 60 volts, so I turned this knob to change it to 60 volt. So I read 60 volt on the meter. So I use this knob to change the voltage to the 60 volt. And now, if I press on this that says continuous refresh, so continuous refresh, if I click on it, I'll see the signal across the capacitor, across the resistor, because we connected the resistor to terminal E1. So this way we can measure the. Now another way of monitoring the voltage is if I close this one and I click on metering. There is a meter here that says metering. If I click on metering, all the meters are going to show up here. So the meters for E1, E2, E3, E4, they're all on. So this E1 is already set up. All I need is to click on the continuous refresh. And you can see that 52 volt, and it's AC. You have the option to change it to AC or DC. But you can see that the voltage across the resistor is measured at 52 point something. It's fluctuating around 52. If you want to read the current, so the first thing is to make sure the power is off. So I'm going to turn the power off. For current, I grab 2 wires. And I want to measure the current. If you look at the circuit here again, you can see the current meter is after the capacitor, going to null. So what I'm going to do, I'm going to say, okay, this one, which is after the capacitor, instead of going directly to null, it's going to a current meter. So I'm going to connect it to this one. We have 2 different terminals, 4 amp and 40 amp. So I'll just go to the 4 amp, and then the other one goes to null. So this way, the current meter, I'm going to show you, the current meter is in series. So this going here and this going here, it means that the current meter is in series in the circuit. So now I turn the power back on again. Always make sure the power is off when you are modifying your circuit, adding any meter or doing any other thing. So this one, you can see that the current is already read as 0.3 amp or 30 milliamp. Or you can go, again, if you want to measure the current on the oscilloscope, you run the oscilloscope, the channel 1. I'm going to set it to E1 is already E1, the channel 2. I'm going to set it to I1. And then if I click on the continuous refresh, I see this one. I better change the value of the scale for the current to a lower value, like 0.1. And you see the current as well as the voltage waveforms on the oscilloscope. Always, again, just for the safety purposes, make sure that you do not modify the circuit, you do not add or remove any cable without this power being off. I hope you were able to use this video to learn about the lab volt units for the power system lab. Thank you very much for watching the video.